Hey guys, today we're going to be talking about enzymes. So much fun! Yay! Okay, so when we're talking about active sites or non-competitive and competitive inhibitors, okay, this is what we're going to be talking about. When we're talking about competitive inhibitors, that's going to be competing with our active site. So you can kind of think of this if you have your keychain full of keys. You're going to have a key that's fitting in the lock, but maybe it's not going to turn. That's going to be actively inhibiting with competitive inhibition, right? Your active site. Well, then we can say, hey, we have this allosteric inhibitor too. So this is like, hey, I'm not even going to worry about keys. I'm just going to bust through the back door in the alley. So the alley allosteric inhibitor, okay? The competitive inhibition with the active site, this one's going to be more easily reversed. So if you think about it, eventually you're going to get the right key into the right hole and it's going to unlock. But with the allosteric inhibitor, this one takes a little bit more effort to reverse. So if there's a question that says, you know, there's a pharmaceutical drug and it's targeting the allosteric site, it's because it's lasting longer. Okay, and remember the allosteric site is in the alley, it's not the active site. Okay, and after the allosteric inhibitor binds, it's going to change the conformation of the active site, therefore distorting it. Okay, we also have our feedback mechanisms. So if we have the substrate, an enzyme, it's going to this substrate, enzyme, and then we get to our product, then we have this feedback inhibition. And basically wherever this arrow is pointing, that is the feedback. And inhibition just means we're going to reduce the activity, okay? We're inhibiting. And so if we say, okay, our product here is going to be inhibiting enzyme A, what's going to happen to this orange circle? Well, the orange circle is going to increase in amount because it's not going to be used up to get to the green triangle. Okay, so the green triangle, the blue square, and then the gold star are going to decrease because they're not being made, but we're not using up our orange circles because of this feedback inhibition. So this level is actually going to increase. Okay, then another thing that you want to remember and is just what these things are called. Okay, so you have your substrate and you have your active site. So then you have your substrate entering the active site of the enzyme. Then the first step is the enzyme substrate complex, and the enzyme is going to change shape slightly as it binds. Okay, then you have your enzyme product complex because you see the color change, so from the substrate it got converted into the product, and then you're going to be releasing the products, leaving the active site of the enzyme here ready to be reused. So make sure when it says like what happens right after the substrate enters the active site, where we're going to be making the enzyme substrate complex. Okay, so remember these 3 steps. Okay, or 4 steps. So I hope that that was helpful. So just remember that competitive inhibition is competing with that like the keyhole in the lock, where the allosteric site, that's actually going to be like using the alley. It's not even messing with the active site. Okay, so those are your keywords. So allosteric is automatically going to be going to the non-competitive, where when you're competing with the actual active site. Okay, and then with the feedback inhibition, wherever the arrow is pointing, that's where that stop sign is getting pointed to, and then everything below that is going to be reduced because you're not making those complexes anymore, but everything ahead of it is going to be increased because it's not being used up. All right, hopefully that's helpful. Let me know. Thanks, guys.